So this is the one where we threat model during development. First thing that I have to make clear is that I will not be using analogies from any TV show, even though the title was there. So if you don't like Friends, if you think that they were not on a break, relax. It's not going to happen. Oh. So first thing, this is where I come and try to establish myself as an alpha geek and see if I can get some of your understanding of why I'm talking about the things that I'm talking. So my name is Izar Tarandach. I am a senior staff engineer at Datadog, working on the security products that are being developed over there. If you guys are familiar with Datadog, it has a long lineage and tradition of observability products. And now that technology is going into security products, so it's a pretty new line. But we're doing some nice and interesting stuff over there. I have been doing security in a way or another since the 90s. So yeah, last century. And for the past few years, I have been poking at anything that's related to the SSDLC, the Secure Software Development Lifecycle. Meaning, I take the things that software engineers do every day, and I try to put on top of them security. How to develop securely, how to design securely, how to deploy securely. I'm also the lead developer for Pytm, OWASP Pytm, which you're going to see in a bit. And unfortunately, I had a packet of really nice stickers for Pytm that look just like the logo, and I forgot them on top of my computer at home. Sorry. I have recently co-authored a book on threat modeling for O'Reilly called Threat Modeling: A Practical Guide for Development Teams. And in it, I'm talking about a lot of the stuff that I'll be talking today, but trying to put it in a way that developers can, basically when we wrote the book, we wanted developers to be able to get the book on Friday, read it over the weekend, come back on Monday to work and say, I sort of understand this threat modeling thing, and I should be able to start doing it. And no less important, I am one of the founder members of the Threat Modeling Manifesto work group, which we're going to, again, hear a bit more in the next few minutes. The standard disclaimer applies. The opinions here are my opinions and nobody else's. I'm not speaking for my employer. I'm not speaking for anybody else. And any egregious mistakes in here are all mine. So what is it that we're going to talk about today? We're going to first do a quick security and threat modeling primer. This is, after all, a development conference. I usually speak to security audiences where I don't have to define terms and whatnot, because most people are expected to understand or at least follow the language that we use. So actually, who here is a security professional? There's always one. Who here has threat modeled in the past? Not bad, not bad. What, 5% of the people? Who here thinks that they will be threat modeling in the future? Oh, nice. And who here has never heard about threat modeling before? Yeah, we're going to fix that today. Cool. Okay, so after we do that primer and after we sort of have level set on what the hell am I talking about, we're going to jump into the meat of the presentation, where we're going to see how you can threat model as a developer. Something that usually security people are supposed to do, but you're going to see how the developer can jump into that. And then questions and whatever you guys have. So, first of all, we have to understand what is security. When a security team comes to a developer and says, hey, I need you to develop securely, where does that come from, and what's the point behind the thing? So if you consider that whatever systems that we develop, they basically have data and some kind of functionality that they provide, right? If it's just data, come on, you have a database. But if you don't have any functionality on it that transforms that data or that exposes that data somehow, your system is not going to be very useful. From a security and privacy point of view, nowadays, what we're trying to do is make sure that whatever system we create has at least 3 properties. And they are confidentiality, integrity, and availability. Confidentiality means that whatever data you put in there only comes out to the people that actually have the right to see it. So unless it's by design, the data is not public access. Integrity means that whatever data goes into the system, whenever it comes out, it's exactly the data that was in there. Nothing changed, again, beyond what the system is designed to do. And availability means that whenever you want to use that functionality, the functionality is there for you. Not very complicated so far. Now, what are the mechanisms that security people or developers have to guarantee these three properties plus privacy? First of all, we have controls. Controls are those things that we can put in the design as pieces or as imported functionality that answer questions like, who are you? Prove it to me that you are you. What is it that you want to do with the system? And here, I'm going to keep a record of the things that you are doing so that I can look back afterwards and make sure that whatever you did was fine. For that, we use identification, authentication, authorization, and audit trails, usually known as logs. On top of that, when we design those systems, we have a number of patterns that we can apply to design. Something like defense in depth, meaning if I'm going to put some bump in the road before an attacker, then it's preferable for me to put 2 bumps in the road so that if the first one fails, then I have a second one to fall back on. I have least privilege. I guarantee that whomever is using the system or whomever is part of the system, whatever principal I have in the system, only has access and rights to do whatever they need and never more than that. Fail secure. I design my system so that whenever it fails in a way that doesn't fail completely open or fail completely closed. Each one of them, as part of the design, has to be taken into account as the workflow, and a choice has to be made at that point. The important thing is that they fail in a way that is secure. They fail in a way that continues to protect confidentiality, integrity, availability, and privacy. And then you have capabilities. The system itself provides capabilities that give the services that are needed to maintain those properties. Things like encryption, things like complexity checks, and things like execution prevention. Things that usually leave one step under the application itself. Now, again, what we work on every day, what we build, are systems. These systems, they have the data, they have the functionality. From a security point of view, they are there to provide value, right? Nobody wakes up in the morning and says, I'm going to design a complete system just because I feel like, even though even that is a value. Usually we want the services to be there for somebody to take advantage of them and somebody else to receive something for that. The problem is that these systems, when they are designed, the design itself can have weaknesses. Parts in the design that were perhaps not thought up to the end or that did not conform to any of those controls and capabilities and patterns that I alluded to in the past slide. And those weaknesses over time can become vulnerabilities. In parallel with that, you could have, for example, what you know as a vulnerability in a library, in a third-party package. Something that comes from the outside that you use and that it's vulnerable somehow. The problem with a vulnerability is that eventually it becomes a threat. How does it become a threat? When you have a threat actor that actually knows of the vulnerability and is willing to exploit it. In that case, what they're trying to do is attack the value that the system creates, and with that, generate some risk. In order to do that, that threat actor needs to have the means, okay? They have to know how to do the exploit. They have to have a motive. They want to disrupt something. They want to capture some of that value. They want to get some value for themselves. And they have to have the opportunity. Even once they have all of those, they have to have the motivation, the will. Again, the motivation is a function of wanting to disrupt that system, wanting to disrupt, to create risk by disrupting the value. Now, What we try to do as security professionals is to stop this chain of events from happening by either doing away with the weakness or patching the vulnerability, or interfering with the will, the opportunity, the motive, and the means of the attacker. Once we manage to do one or more of these, then we can rest somewhat assured that things are going to proceed the way they're supposed to. So, with that, what is the process of threat modeling? In one line, a threat model is nothing but a function of some system representation, some model of whatever it is that you are building, and threat elicitation. Some result of a process where you take that model, you figure out where it's running, what the operating conditions are, and what could go wrong. You make a list, you got threats, that's a threat model for all intents and purposes. What's the process of modeling those systems? You basically look at whatever is it that you're building or that you're planning to build or that has already been built, and you figure out what the elements, the interactions between these elements are, and the attributes of these elements may be. So you could say that a client is an element, a server is an element. Whatever they talk between them is a data flow, and the operating system that they run on, or whatever third-party dependencies they may have, or whatever encryption scheme they use, these are all attributes of these elements. Once you have that, you got your model, you know exactly what is it that that you are focusing on, then the way that a security professional would go about it would be to look at the elements, look at those interactions and attributes, mix them somehow with their experience, use a bunch of libraries like CWE and KPAC and ATT&CK and OWASP that make absolutely no sense to you right now, and I'm not going to go into all of them, but just refer to them as catalogs where security experience is listed. So you are able to go in there, see how things can go wrong, see how they usually go wrong with a specific element or a specific attribute, and you get that list in front of you. From there, looking at the weaknesses and the vulnerabilities that get identified, the security expert would figure out, okay, these are threats, these are things that I have to deal with. Assuming that there is more than one, and usually there is more than one, there comes a process of putting them in order, because we can't usually fix all of them. So using some form of risk sorting, risk prioritization, and CWRAF and FAIR and RMF are just examples of what could be used. They'll come up with a list of risks. That list is usually sent to the developers, and more often than not, it's ignored. Then what follows is a lot of back and forth, because developers, as you guys know, are a very smart bunch, and they don't like to be told, this is what you have to do. But they love asking, why do I have to do this? So one of the big problems with threat modeling, especially when done by somebody who is not the developer, is how do I explain to the developer why this is important to me? Especially because the developer has a completely different list of priorities. They want to put out more features. They want to finish the stuff that they were doing. They don't want to stop whatever flow they have going to go back in time 3 or 6 months and look at something that they did then that they have to now secure. Okay, so now we get to the meat of the question. To give myself a framework, I'm going to use the threat modeling manifesto. And now I'm assuming that you already know, like, in at least a very shallow way, what is a threat model, right? It's that function of representing the system and figuring out what are the threats to that system. Now, the threat modeling manifesto is a piece of work that came out in 2021, I believe. And it was the result of collaboration between 15 people who are very, very, very experienced in threat modeling. And we had people from academy, people from industry, people who actually develop methodologies for threat modeling and research threat modeling. And the reason why I have the podcast there in the bottom is that the 15 of us agreed that it was one of the most productive and interesting collaborations that we ever had. Imagine 15 people who really barely share any kind of background, actually managing to, I think it took us between 4 to 6 months, converge into something that parallels the Agile Manifesto. So it's in there just in case somebody's curious to see the behind the scenes of the thing. But basically the threat modeling manifesto, the first thing that we had to come out with was a formal definition of what threat modeling is. Because it's very difficult to talk about something and how it should be done and how it shouldn't be done if we can't agree what it is. This was basically the hardest part of the whole thing, I think. It took us a long, long time for 15 people to agree what is it that we're talking about. And the definition that we came up with is that threat modeling is analyzing representations of a system to highlight concerns about security and privacy characteristics. So again, that one line, that function, threat model is a function of modeling and threat elicitation, gets translated into this. Only that now we add privacy to the mix. After we had the definition, then we had to go back to, okay, so now what do we tell people that practically is threat modeling, right? And for that, we used the definition, the framework that was proposed by one of the members of the group, Adam Shostak, who, anybody who heard about threat modeling basically heard of Adam. He was one of the first authors to put a book out there about it, and he frequently speaks in all kinds of conferences. And he has a very uncanny talent to reduce things to their most absolute factors. And he did that to the process of threat modeling. And what he came out with was the framework, the 4 questions framework. So basically, anybody who's doing any kind of threat modeling, using whatever methodology they may be using, is actually answering 4 questions. What is it that you are working on? What is it that you're building? What's the thing that you are threat modeling? What could possibly go wrong? Figuring out those threats. What can you do about it? Once you have the threats, how do you identify mitigations that work with the design and the purpose of the system that you're building? And at the end, some auto-reflection. Did you do a good job? Is there something that you can learn from the process of threat modeling that you can go back and do better next time? It's funny that we spent a long time trying to figure out if there was something that was left out from these 4 questions that we could add to it. And at the end of the day, we couldn't find anything else. These really bring the whole idea down to its simplest form. Now, after we said, okay, we have a definition, we have the simplest form of doing it, the next step for us is to tell people, listen, these are the principles of the thing. These are the things that we need people to take away from the exercise, right? So we came up with the values and then the principles. In the principles, we have patterns and anti-patterns. So we copied this format straight from the Agile Manifesto, if anybody is familiar. And it came out pretty nice, I think. So when we say that we value these over that, we are definitely not saying don't do that. We are saying do whatever you need. But we think that if you do this thing, it's going to be better for you than doing that thing. So the first value is a culture of finding and fixing design issues over checkbox compliance. Many times threat models come not from the need of finding those threats and mitigating them, but because somebody said so. Checkbox compliance. Somebody comes and says, we have regulation 123 ABC that says that there must be a threat model. So somebody goes and creates something and calls that a threat model. But we think that if you can instill into people the idea that finding and fixing those design issues in the beginning is going to save money down the road and it's going to save time, and most important, it's going to save panic. If you ever seen a bunch of developers trying to solve any kind of problem, basically under fire as the thing is happening, you know what I'm talking about. Then we value people and collaboration. over methodologies and tools. Many times you figure out a methodology or you buy a tool, you spend a lot of money in the tool. And you know what? From now on, everybody's going to use the tool. And from now on, everybody's going to enjoy using the tool. So that happens with threat modeling as well. There aren't many tools out there, and most of them do a very, very good job, but some of them may be a bit rigid. So what we wanted to stress here in this value is that it's more important to have the people understanding what they're doing and collaborating over the threat model than just fixating on some aspect of the tool that everybody has to click on and put whatever values in there, click some magic button, and get threats. A journey of understanding over a security or privacy snapshot. That goes together with the compliance. A threat model is a living thing, right? It's not some document that somebody prepares and it goes into the first drawer and never gets looked at, or let's do it again in 6 months. So by a journey of understanding, we are recognizing that, hey, you know what? This is difficult. And it's not going to be perfect the first time. You will have to evolve over it. Doing threat modeling over talking about it. Many times, companies say, we need a threat model, we will bring a consultant, we will train people, and we will have a threat model. And then they spend a lot of time talking about how they're going to do that. What we say is stop talking about it, just go and do it. It's going to suck, it's going to suck, it's going to be terrible the first time. The second one, because you're going to ask yourself, did I do a good job? And the answer is probably going to be no. You're going to learn something. So the second time is going to be easier. The second time is going to bring more value to you. So just keep doing it. And in the end, continuous refinement over a single delivery. And that goes to, again, just having the threat model that somebody says, we need the threat model. Yeah, now you have a threat model, but if you don't refine it, if you don't work over it over time, you basically have nothing. In terms of principles, we said that the best use of threat modeling is to improve the security and privacy of a system through early and frequent analysis. Once upon a time, many of you have probably not experienced this in your professional lives, but it used to be like that. You would have a design, implementation, testing, deployment. Call that a product. Nowadays, you have agile, you have all kinds of different methodologies, and things go in a circle, and they happen at all times, and they happen out of order. You may be testing stuff even before you wrote it. It's awesome, right? So what we are saying is that you should do threat modeling as early as and often as you can. Threat modeling must align with an organization's development practices and follow design changes in iterations that are each scoped to the manageable portions of the system. That's every time that I try to read that thing, I stumble. Basically, what we're saying is, you work in sprints, awesome, then threat model by sprint. You work in stories, awesome, threat model by stories. You work waterfall, by all means, do it at design, carry through to the implementation, but do it in cycles that match the culture of wherever it is that you are working. The outcomes of threat modeling are meaningful when they are of value to stakeholders. That, for me, is the most important of all. If you get to the point where you ask yourself, did I do a good job? And your answer is, there's no value here. Even if you did a perfect job, but the people who are supposed to fix those issues, the people who are supposed to fix those threats, don't see any value in the process, then don't do it. There's no point in just wasting your time, wasting their time, and all the grief that goes together with it. And at the end, dialogue. Threat modeling is a team sport. You cannot threat model by yourself. Well, you can if you are the sole developer of a system, something that only you know about, definitely. But in most real situations, threat modeling is something that you do in a group. So foster that dialogue, figure out who can bring you the information that you need, and use that. In terms of patterns, the systemic approach, it's easy to treat threat modeling as something that you just throw spaghetti on the wall and see what gets in there. If you do it in a methodical way, if you scope things the right way, if you look the way that I do, from the outside in, trying to figure out what the threats that come from the outside might be, you're going to get a better effect than just randomly throwing threats and seeing if they apply or not. Informed creativity. It's very easy to fall into the pattern of, I have a list of threats, if you remember the slide with the elicitation, and I'm going to go one by one and I'm going to figure out if they exist in my system or not. Sometimes you have to step away from lists. Why? Because developers are creative people, intelligent people, and they are every day creating new stuff. And you know what? New stuff brings new threats. So if you keep driving and looking at the mirror at the same time, which is basically looking at problems that were in the past and see if they repeat, you're going to miss the bumps in the road in front of you. So try not to do that. As we said, dialogue and getting different viewpoints. The way that a developer looks at the system and the way that a QE person looks at the system, completely different. So when you're threat modeling, make sure that you include everybody that you have. Everybody that might give you a different viewpoint on the system is a good input for a threat model. Have a useful toolkit. Build your tool belt. That means that most probably over your life, or even over the life of one single system, you may need to threat model in different ways. There are many methodologies available, but you shouldn't choose one and just stick with it. Just keep an open mind, get your tools along the way, figure the things that work as you do them, but build the toolkit and use it. And theory into practice. Even though it's a very open-ended process, it's useful to look at what other people did before and say, can I learn something from this before I invest time and effort into doing it? The things that absolutely do not work and that actually hinder your progress in threat modeling. First one is the hero threat modeler. Do not fall into the pattern of telling somebody in the team, you're responsible for the threat model. That person goes away, comes back 2 weeks later, like Moses coming down from the mountain saying, here's the threat model, right? It's probably not going to be a threat model. Exactly because it doesn't have all the variation in the viewpoints. That person may not know all the design details. They may not even know all the business cases that would inform a threat model. So again, it's a team sport. Admiration for the problem. Sometimes people look at an aspect of threat modeling, and it may be a particular threat. It may be a part of the system. It may be even the fact that they are threat modeling, and they get paralyzed. They don't know how to move forward. So you know what? If you don't know what to do, just do something. Just keep moving. Stagnation is definitely one of the big enemies of this whole thing. The tendency to overfocus. Again, this is something that's extremely human. We tend to focus on the things that we know well. The problem is the threats are going to be probably in the places that you do not know as well. So try to be as broad as you can. Try to analyze things and give the same weight to basically everything. Don't focus on something just because you know it so well. Turn on your flashlight and go look into those places that are a bit darker. And perfect representation. This is a really important one. We're going to delve a bit on it. There's absolutely no single ideal view. There is that famous saying by George Box that all models are wrong, but some are useful. Threat modeling is a really, really good example of that. So, in that sense, this is a DFD. This is a data flow diagram. You may have seen this as a developer in documentation. And basically, it's trying to explain what the system is, right? So you have circle A that represents one single process. You have circle B that represents a process of processes. And you have C that is some kind of data store. And then you have data flows, the number ones, in between them, and a trust boundary in the SQL representation. Meaning, between A and B, there are different levels of trust. Now, this is enough for somebody to look at and start already coming out with value, security value out of it. But it can also be simpler. So it's a different representation. It's a version of DFD called DFD3, which is supposed to be simpler. And it chooses a smaller subset of symbols just to express exactly the same things, but at the same time make it less cluttered. So you are simplifying that representation while not exactly adding any more detail. And then you have another kind of representation, which, as you can see from the side, is exactly the same system, exactly the same data flows. But it's what we call sequence diagram. And in here, you have a bit more information in terms of who talks to whom and in which order. So if you imagine an axis going from the top down, that's time. So you would see that the first arrow between the purple and the green means that there's some kind of communication between them. And so on and so forth. And as you can imagine, it's really useful, you may have already seen, it's very useful to analyze protocols or dialogues or anything like that. The important thing is that, again, it represents exactly the same system. The same way that there's no perfect representation in terms of how do you model a system, there's no perfect representation in which methodologies of threat elicitation you're going to use. So just 4 examples. The first one is TARA. It's called Threat Assessment and Remediation Analysis. And this one is what we call an attacker-centric methodology. It focuses on what is it that an attacker can do that's going to generate a threat to my system. Or you can use STRIDE. Anybody who ever heard about threat modeling at some point is going to see the acronym STRIDE. It's a technique invented at Microsoft. And you use it to find threats that lead to impacts like spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. You are basically using your knowledge of what could go wrong to generate any of these impacts. In parallel of that, you have Linden, which is exactly the same thing, just using a different acronym to look at issues of privacy and not security. And then at the end, you have CTM. CTM is continuous threat modeling, and is an approach that's geared for the developer to work on. So the first one, Tara, you definitely need a security expert to do it. Why? Simply because it uses the approach of think like a hacker. And I like to say that you can put me in a kitchen and say think like a chef. Absolutely nothing is going to come out of it because I don't know how a chef thinks. I don't know how they work. I don't know how their tools work. I don't know their process. I don't know anything. So you can go and just order a pizza because there's no food coming out from me. And it's the same thing, and it kills me every time that somebody looks at a developer and says, what's the problem? Just think like a hacker. Developers have a huge body of knowledge, but so do hackers, so do attackers. There's not a lot of crossing between them. So asking a developer to all of a sudden, when they are so used to creating the best solution for a problem, to think of a problem on top of that one, without knowing all the techniques, without knowing the tactics, without knowing the procedures, I think that it's a bit of a stretch. And that's basically what caused me to invent CTM, to create CTM, sorry. So, a bit of a show and tell, CTM, Continuous Threat Modeling. It is supposed to work with DevSecOps or DevOps or SecDevOps or whatever you call it this week. It's always changing. How? Developers are now the new architects. Gone are the days that a developer gets a specification and it's supposed to just go and write to that specification. The design and the implementation now, they take longer, right? They happen together and they go cyclic. And those cycles can be longer or can be shorter. The training that we give to developers in terms of security, and just security, really sucks, okay? It's a well-known secret in the industry that we keep throwing training at developers, and this is a pet peeve of mine. When you want to check it, basically what we do is we give them a question with 4 answers. 3 of them are ridiculous. 1 is explicitly the one that we expect. They go and they choose that, and we say, nice, now you're able to develop security, right? Of course, there are some other options like all kinds of coding arenas and stuff like that, which are marginally better. But let's be honest, the training that we give for security development, sort of not the best. And we need a way to shorten the flaw to fix kill chain, meaning between the time when a developer creates a piece of code and the time where we find a flaw in that code, it could go months. That person may have moved projects even. And yet we expect them to be able to go back to that piece of code back in time, figure out what's wrong with it based on the input that we as security professionals give them, and fix it. Now, the good thing about threat models, and this is something that sort of happens when you've seen a number of them, is that threat modeling is an activity that's part of the secure development lifecycle. But at the same time, once you have a good threat model, you can use it for a lot more than that. For example, security testing. Nowadays, you ask somebody, hey, do you do secure testing? Most of them are going to say, yes, we have this tool that basically you click on a button, give it an IP, it throws a bunch of payloads at whatever you have, and it sees if something breaks. That's what people think of as security testing. Why? Because there is no mapping between what the problems might be and what the controls that you are expected to have put in place are, and how you're going to test those controls. Threat models are great for that. Threat models are great whenever you have a new member of the team joining, and they need to know all the little things about the system that they're going to work on, and it gives them a roadmap and an overview of the system that they're working on. The case for continuous threat modeling came to me after I saw this tweet by Jim Manico. Now, Jim Manico is really one of the best, if not the best, security trainer available nowadays. The guy knows everything about training developers for security. And he says that in his experience, all software developers are now security engineers, even if they admit it or not. And why is that? Because they're putting out so much code, and that code is in so many places, and there is no adult supervision that whatever security flaws they create are out there. Until somebody figures them out, they are out there. So, in a pinch, what is this continuous threat modeling thing that I'm talking about? Don't panic, I'm going to zoom. You don't have to read the small letters. But it's basically two phases. The first one is a baseline. We create a baseline threat model just to figure out where we are. And the reason for that is that many times you start doing the threat modeling when the system already exists. Rare are the occasions nowadays when threat modeling starts when the system starts right from the beginning. And then you have a loop that does the continuous part. So let's zoom into them and see what they are. So the baseline part begins when somebody realizes that they need a threat model. How am I doing for time? Yeah? So it starts when somebody figures out that they need a threat model. Oh my God, I need a threat model. What do I do now? So the whole team comes into a huddle, or at least some manager comes into a huddle, and says, okay, now you have to have a threat model. You start by modeling the team, by modeling what is it that you're working on, as we saw. Then you figure out the threats. You document everything that you found out. You got a threat model. Hey, that's great. But the system keeps going on. The system keeps evolving, right? What do I do with this document that I have in my hand right now? If the system is not being developed anymore, it's in maintenance mode, or for whatever reason nobody's working on it, take the threat model, put it on the side, review it in a bit, after you mitigated everything that you found, of course. But if it is being developed, then the next step is for some developer to pick up the next story in the backlog, look at it, and now they have a decision to make. Does this story have any kind of security value? And what's a security value? It could be something as simple as I have to open a new port in the firewall. That's a security notable event, right? You are taking the attack surface, the number of ways that that system can be attacked, and you are adding something to it. So somebody better know about that, what's happening. Somebody better think about the things that could go wrong if that port is opened. Or at the same time, the developer could be adding a new process, or adding a new actor, or creating some different interface. And all those things are ways for uncontrolled input to come from the outside into the system and somehow influence it. So all these things have some security value. At the same time, sometimes the story is simple like update documentation. In that case, chances are that the security value either doesn't exist or it's negligible. If there is security value, what is it that we expect from the developer? For them to threat model every story, meaning look at whatever they're doing, do the security right thing, document that in a ticket, and pass it forward. Now, who looks at that ticket? Somebody that we declare to be, or that we volunteer to be the threat model curator. That person does not have to be a security expert. The only thing that they need to do is stay on top of the queue and figure out that every ticket gets included in the threat model when they need to be. This way, what we are guaranteeing is that that threat model is evolving together with the system. As the system is written, as the system is modified, the threat model is always up to date with it. So, threat model every story. Again, you build a baseline, you include everybody. You can use whatever methodology you want. Now, many teams get to this and say, we don't have a methodology. Great. So CTM offers what's called a subject list. That subject list is, if I'm not mistaken, 12 items long, and it looks at areas, at subject areas that usually have security problems. So for example, authentication and authorization, or the use of cryptography, places where usually the design fails. And then for each one of those areas, there's a number of leading questions that is offered. We're going to see an example in a second. And the point there is to take the team through that list and have a discussion, an open discussion. Have we done the right things in each one of these areas? That's sufficient, or has been proven sufficient in my story, to give you a baseline of where the system is at that moment. You find out who's going to be the curator, who's going to be the person who's going to be tending to the queue that has the tickets that the developers are going to create. You are going to tell to your developers, hey, every time that you open a story, figure out if it has some security value. If it has no security value, then continue as usual. If it does, then either fix it, create a mitigation, or mark it as something that somebody has to take a look at. Eventually, it will come a point where the developer is going to have enough sense, enough security-mindedness to say, I know that there's security value in this story, but I'm not sure that I know what the right thing to do is. So I will need somebody who has a bit more security experience to come and take a look at it. So that gets documented and passed as a ticket to the curator. And then you just have to make sure that your curators are on top of the queue. But the question now is, and if you remember, I complained about the security training. How do I make sure that the developers know what has security value or not? So Richard Feynman, the famous physicist, said, he did not tweet it, he said it, teach principles, not formulas. And what I mean by this is that many times today, the training that we offer our developers says something like, if you are working in Java, and you want to avoid SQL injections, here's the stanza that you have to use. Here's the ORM that you have to call. Here's the thing that you have to write. And 3 weeks later, the same developer needs to do something in Python, and they have to deal with an SQL injection. And now they have to go back and see, okay, in Python, how do I do this? What's the right stanza in Python? On the other hand, again, developers are smart people. They want to do the right thing. If I explain to them what is the problem with injection, why injection is a security problem, chances are that when it happens, they will know by themselves either how to fix it in whatever context they're working on, or where to go to get the right answer. So for the baseline, we have the subject areas where we point developers towards security subjects and say, what are you doing about this? But for the day-to-day, there's a checklist. And that checklist just verifies that the developers are following the principles of security. The things that security is based on, which happen in every single context or stack that they are using, and that they have enough material to do the right thing in there. So, There's a handbook, and the reason that you see Autodesk in there is that the first place where I implemented CTM was at Autodesk 4 years ago, 3, 4, 4. And when you're going to GitHub and look for continuous threat modeling, what you're going to get is the handbook that was written at Autodesk. But still, useful for everybody. And the handbook is the thing that you give to the team to say, here's how you're going to do threat modeling. And everything is explained in there to the last detail, including what the output looks like. The subject list. This is just the top 4 items. There are 12 in there. But this gives an example of what are the leading questions that you're going to use when you do that initial discussion to get the baseline threat model. So for example, for the access control, is access granted on a role-based fashion? Are all access decisions relevant at the time that access is performed? So basically, it's leading developers to ask themselves, whenever I'm checking the access control for something, am I doing it as close to the actual access as possible? Or am I giving a delta in here where things may change or things can be influenced? I'm going to say this later on, but I'm going to already alert you. This is the hardest thing to get right with teams, because many of them look at the subject list and they refer to it as a check mark thing. Yeah, we do this. Yeah, we do this. They don't take the thing to the next step and develop discussions on top of those subjects. Now, the checklist, the one that the developer is actually expected to use every time that they develop a new story. This that we see in here is a page from the space shuttle, I think that just before it lands. And it's the traditional checklist. It's a bunch of steps that you go through, and basically you are checking. Is this state right? Is this done right? Is this thing flipped? Right? But that's not good enough. Because then it would lead the developer to a point where they actually write their code, and then they look at the list, and they say, oh, yeah, I did that, I did that, I did that, I did that. And the mechanism that gets formed in their workflow is that first I do my thing, then I do the security thing. So instead, CTM adopts a different format of checklist, if this, then that. So the first box, the if this, is written in developer language, not security language at all. And it just says, hey, if this is the thing that you are going to do, then do that. Then look at the other side of the list, which has a bit more security language, just because it has to, but it's made of single sentences that already explain what the intent is. As you can see, they are blue because they are links, and if you open them, they look like this. Tops 1 paragraph, no more than that. Always with some kind of link that if the developer feels the need, they can go and explore that subject more. But at the end of the day, if you were to print the checklist, it would come both sides of 1 page. We are not talking about giving every developer here a book about security and saying, read this book every time that you develop a story. We are just giving them 1 page of paper and saying, as you develop, before you develop, as you think how you're going to do this thing, go over this. And the intent here is to create muscle memory. We want to create that sense where, after a number of repetitions, the developer is able to get this checklist, chuck it, throw it away, because now they have the security sense. Now they are able to say, I know what has security value, and I sort of know what to do in those cases. But for sure, I know where to go for more information. So just to recap, baseline, designate a curator. Tell your developers to threat model every story. Give them the checklist to work with. Make sure that the curators are on top of the tickets. And that's basically all there is for continuous threat modeling. How have product teams reacted to this over time? What? Sometimes they absolutely have no idea what I'm asking from them. And this happened more than once. And then slowly you go back and you get them to do it again. This is still too heavy. Some people look at the process and say, wait, you want me to create tickets, you want me to read checklists. This is too heavy, I'm not ready to do that. Some of them will try it, but they'll have the fear at the end of, how do I know that I did everything? I don't know everything about security. How do I know that I did everything? And this goes back to the threat modeling manifesto. I don't care if you did everything. Just do what you can. Because the next time that you do it, you're going to do it better. And this was the one that I really enjoyed. I never saw a room of architects excited about threat modeling before. And this happened after a workshop that was given just for architects. And the chief architect came to me later on and said, listen, first time that I see these people excited about this kind of thing. So it's not perfect. As I said, it's difficult to convince teams that the subject area list is not just a checkmark thing. The resulting threat model is not going to be perfect, but it will be evolutionary. Sometimes you do need somebody that actually knows security from beginning to end to enrich the thing. And it's garbage in, garbage out. As much effort as you put in, that's what you're going to get out of it. Pytm. Pytm is a tool. It was created to work with Agile to support CTM, but the two of them are completely independent. You don't need you don't need both of them to exist together. And it's based on the fact that developers want to write code. Developers know how to write code. Developers hopefully like to write code, right? If you get a developer and you tell them, hey, now I have this graphic interface that works only on Windows and they are a Linux person or a Mac person, they're going to look at you sort of like, what do you want from me? So Pytm tries to reach the developer where they live. It's a Python library that you can use to code your threat model and put it in the same repository as your code. And hopefully both of them are going to evolve together. What does that look like? You define the components, you define the data flows in code. You can generate either a data flow diagram or a sequence diagram. You can annotate the components that you created with their attributes, and then you can generate a report running those elements and their data flows and their attributes through an engine of rules that figures out threats that are known. This is the shortest possible Pytm script. It imports the elements that you're going to use. It defines the basic threat modeling object. And at the end, it starts the loop by calling process. Now, of course, this is not going to give you anything. But what it can point out is that this is the most Python that somebody needs to know to be able to use Pytm. The whole approach of the thing is you have an object dot an attribute equals a value. If you are able to write that much code, you are able to create a threat model using Pytm. How do you do that? So in between defining the threat model object and calling the process, you start by defining what your elements are. What are the things that make up your system? In this case, we have an actor who's a customer. We have one process that's the client / the GUI, the server, and the data store. The data store is some kind of database. Next step, now that we have the elements, we're going to define how they speak to each other. Now, this is the most basic way of defining the data flows, and it's a source and a sink and a representation of the data that goes in between them. Just having that, as soon as you run the script that you wrote, you are able to get the diagrams. So the top one is a data flow diagram. The one in the bottom is a sequence. If you look at them, you're going to see that they are exactly the same thing. They are totally equivalent. The only difference here is the kind of representation that you are getting out of it. Because remember again, there's no perfect representation. In some cases you want one, in other cases you want the other. Pytm is ready to give you both for the same price. But these representations, as they are, interesting as they are, they don't offer any security value. They start offering security value when you are able to say, remember the trust boundaries, when trust starts changing between elements. So in Pytm, you can define a trust boundary and say which elements live inside and outside of that boundary. Once you run again the script, you get your data flow with now a very clear representation of the levels of trust between the different elements. So now you can start asking yourself, when I'm sending the customer data between the client and the server, I have a change of trust. So where is that identity stored? Who's doing the authorization? Who is doing the authentication? Am I able to spoof this communication somehow? Tamper with it. So that's when you go one level down and you get your elements and you start giving the attributes and the values. These are just some examples. What I want to call your attention to here is the last line of the first element, db.maxClassification equals classification.restricted. That basically means that that data store that I have can only hold data up to a restricted level. Then on the bottom, the last line that I have in there is that the data flow between the DB and the secret DB can have data up to secret. So now you are extracting security value by comparing the levels of data and saying, oh, if I have a data flow that carries secret data, but one of the sides is restricted, I probably have a problem in here because there will be top secret data flowing over a data flow that can only have restricted. That kind of thing. So that's the power of the attributes. Then we have a reporting engine, a template, that actually was stolen. That's documented in the code, but it was stolen. And what it does give to Pytm is the ability to give any kind of textual output. You just write your template, run it through it, and you get your text. Using Pandoc, we're able to get any kind of that output and transform it into something else. So this is the result of the example templates that we have, the basic example template that we have in the repository. And as you can see on the top, it's going to put the DFD. Right after it, there is a dictionary of data flows, one table that says, hey, these are all the data flows that you have in your system. A data dictionary, which is something that many times security people will ask for, and developers will say, we don't have one of those, but it helps you understand what kind of data is going through the system. And then at the bottom, you have a list of potential threats. Now, this was an HTML template, so you can see that the small triangle in there is closed. If you click on it, what you're going to get is the details on the threat that was identified with the target element, meaning where is that threat happening, the average severity. We currently do not have a calculator that takes into account all the attributes and thinks, how bad is this thing that we just found? We present threats that have an average severity and say, hey, usually in other places where we've seen this specific threat is a medium severity threat. We plan to improve on that on the next versions. Then you have an example instance. So whenever this threat is exploited, how do things work? How is the exploit done? Mitigations, what can you do to solve this problem? And outside references where you can go and get more details about that specific threat. Bunch of resources where you can find the threat modeling manifesto, my book, the repository for Pytm, the repository for continuous threat modeling, 2 other books that are extremely valuable if you are going deep into threat modeling, Adams and Brooks. And at the end, the SafeCodes tactical threat modeling. SafeCode is a consortium of companies like Microsoft, Boeing, Dell EMC, Adobe, all kinds of big companies, and they put out a lot of developer-oriented free content in security. So they have training decks and they have papers, and this one is a pretty good one about tactical threat modeling. That's what I had for you today.